line selected. So that might.
All right, we good? Perfect. Hi, I'm Troy Grossfield. I'm going to talk to you today about Mongo. I formerly was on the community health team. Recently joined the Lights On team, and we're going to build a new website there using a new framework, Python and Django. And yeah, give a view into all the data. So, talk about MongoDB and NoSQL. It's more about MongoDB than it is about NoSQL, but the same principles apply, and all of its awesomeness. So what is MongoDB? Mongo comes from the word humongous. It's a scalable, high-performance, open-source NoSQL database. And it's going to make your life a whole lot easier. Once you start using it, it's something that it takes you a bit to get used to because you're stuck in relational land, and to get out of that mindset of storing things it definitely takes a bit, but once you're sold on it, it's really hard to go back. Everything is stored in JSON-style format, and it's actually BSON, which is binary JSON. And there's only subtle differences, of which it's not really worth getting into right now. It helps with searching, and it's supposed to be more space efficient, but in the end, it's pretty much just JSON, and it's awesome. Terminology. So we've got database, collection, and documents. So basically, you have a database full of collections, which are pretty much tables. You can think of them as tables. And then we've got documents, which would essentially be rows within your collection or your table. Why should you use MongoDB? It's hard to express this stuff until you actually start getting into it and start using it, but it's flexible. You have a dynamic schema, so anytime you want to add something new, you just simply add a new key and roll with it. I like that ringer, man. If you want to stop using something, you just basically quit using the key, and then once you stop using the key, if you want, you can go clean up your database and just make a simple query to go unset all the field names that you were previously using. It's fast, so indexes are stored in memory, which alleviates the need for additional cache, which is something I was actually a big fan of. So previously on Cerner Health, we used Oracle and Memcached as our cache. And with Cerner Health Wins, we just use MongoDB and basically put in everything in indexes, and it works pretty much the same way for you. So it handles that for you, which is awesome. A few things to be careful about, which we'll talk about a little later, because if you put everything in cache, then you might run out of cache, and then you do disk reads, which is pretty expensive, and it slows things down quite a bit. It's easy to scale, so we're actually hosted out on Amazon, and one thing that Amazon does really nice is the ability to horizontal scale. So anytime we need to add additional replica sets, if we were doing a bunch of reads to our secondary to our replica sets, instead of reading from the primary master Mongo. Atomic updates. So all fail or all succeed. Basically, when you make a call, that single call is either everything is going to succeed with it or everything will fail with it. So if I had a few things going on in there where I wanted to pull off a tag from a blog post and also update the content at the same time, it's either all going to be successful or none of it will be successful. It won't give me, okay, well, I removed the tag, but it didn't update the content as well. Now, one thing to be careful there is if you make multiple calls to the database, they are not atomic. So if you made a call to a single call to update the content and a second call to update tags or something like that, if something fails along the way there, that does not roll back because it's non-transactional, which you'll see why not to use MongoDB. If transactions are a big thing, a big part of your usage, then this might not be for you. You can get around that a lot of times just by only making updates, put updates that are that you would all want to succeed or fail. So don't ever have something that goes and updates something and then it comes back and tries to update something else, and the two are very, very dependent upon each other. If one fails, then that's going to cause some issues. So each document can only be 16 megs, and that's more of a design thing than anything. Just make sure you're not putting in loads and loads of data in a single document and you should be fine. Even then, 16 megs is pretty big, so it's not really, you haven't really ever hit that constraint yet or needed to worry about it. So if you think about it like it's in JSON format, if you have keys and you go into Mongo and actually look at your keys, if you use long key names, that's going to take up a lot of size and slow down searches. And if you have really short keys, like single letter keys, it gets really confusing when you go into Mongo because you don't really know what the fields are and what you're actually dealing with. And we'll get into that a little bit in a minute here too. So if we look at some of the MongoDB syntax, this is just very, very basic. You can see the inserts. You can use a single document, or you can enter a list of documents all at once. You can see the select criteria, and we'll elaborate on these all a little more. One interesting thing to point out is the update. So it's got a feature called upsert. So basically, if I go to do an update on something that doesn't exist, it'll actually insert it if upsert is true. Multi is, am I dealing with one row? Do I want to update one row? So should this criteria only match one row, or should it match multiple rows? And if it does match multiple rows, should I update all of them? If that's set to true, it'll update all of them. If it's set to false, it'll only update the first one that it matches. And then remove is pretty basic. What do you want to remove? So we'll go through a blog post example. We'll do your create, your retrieve, your updates, and your deletes. These are some of the update methods that we can use. We're not going to go into detail on all of them. And for the sake of time, I actually won't even discuss them much. Thanks, Brian. But it's very interesting. We'll get into some of them in this example. So let's define our model. Okay, we'll do a blog post example. So our blog post has an ID, a name, content, and the author that created the blog. And with blogs, you would traditionally see something like comments and tags. So with this, and if you're in SQL world, you can already see that this is likely going to be 3 tables. Now, if you're doing it in a NoSQL land, it's all in one document. So there's no need for all these extra metadata fields to point back to another table which references this other thing, which blah, 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 blah. It's all stuck in one document, which is nice because then I can do a retrieve on, let's say I know the document ID that I want to go for. Well, it's ID 12345. Well, it pulls me that back with all the information about that document, so I don't have to do all these extra retrieves, which is nice, and it kills all the, it alleviates all the need for the overhead. Well, this points to this and this points to this. It just gives me what I'm looking for. But this is the general layout, JSON structure, or BSON structure for MongoDB. So you can see in this example, we just have name, author ID, content. We've got a list of comments, and each comment has its own dictionary, so you can embed other objects. And then tags, which is just a list of tags that I wanted to give this blog post. So let's dive into some code examples. So if we're in a shell, I've already defined 2 documents. Try to get this so you guys can see it. You guys see that okay in the back? Yeah? No?
If you can go to view, maybe you can increase the font size a little bit. Or is there an option on the view?
Yeah, I can change the font size. I just wondered if you guys could see it.
Yeah, I think in the back.
Alright, so I have 2 documents defined. Just simply come in here. It's basically the example I was just explaining to you. It's got all that same content in it. So I define it as a document, and let's say I want to go throw that in. Well, first let me show you. So I'm going to log out of the shell and show you some very basic commands. So get into my Mongo shell and say, okay, well, show me the DBs. These are all the different databases I have currently in this Mongo instance. So we're going to go into tests. So we just say use test. So now I'm using the database test. If I want to see what collections are there, or as some of you would know as tables, do show collections. And this will show me all my collections. So now we're going to create a new one called blog post. Now I actually don't have to go in and explicitly create this. It'll do it by default when I go and insert these documents. So again, I've got those two documents. I just pasted them back in. Now I want to go and insert those. So the command to insert is just simply db dot whatever your collection name is, insert. So now when I do db dot blog post dot find, the dot pretty is just for printing purposes. You'll see that I have two documents inside of blog post. These are both the ones I just added in. So if we want to do some retrieval, just want to make sure I don't miss anything here. I'm showing you guys stuff. So if we wanted to do like, let's go retrieve by ID. Okay, and you also might know this, see this object ID. Every time Mongo enters something in, if you don't override the underscore ID, it'll create this Mongo object ID, which is guaranteed to be unique. However, they're kind of a pain in the ass to deal with. So what we do on some of our other solutions is we just override that and we explicitly set it so it's more predictable. So let's go ahead and grab this blog post by ID. You can see these both have different IDs. So we'll say db.blogpost.find1. What's my criteria? Got ID of that. So see, that's a way to retrieve one if I'm going for a specific instance. Or both of these have the same author ID. So if I'm finding many, I just do a find and I do author ID of that guy. And you'll see that two are actually brought back for the sake of printing purposes because they were both by the same author. So that's a few ways to retrieve. Let's see, what else do we want? So you can also change the way you retrieve things. So for example, if I wanted to pull back everything about this blog post except for comments, we'll use we'll do find all. My criteria is just an empty dictionary, which basically, or JSON object, which will basically return everything. And then I'm going to say I want everything but comments, so don't give me any comments. So then I'll return that. Let me print this out nice for you guys. You'll see it returned everything except for comments. And alternatively, if you wanted to do just give me the comments of all these, you could do the same thing just by simply doing comments of one. Then it returns just the comments by those blog posts. Let's do some updates. So this first one, we're going to take where this author is. So this author was the author of both of these posts. We're just going to add a new key called isFeatured. Let's say we change our minds. We say, okay, well, we want to show where all the blog posts are featured by certain authors, and we go and write a script to do this. Well, this is just a simple single command that's going to go through, and everywhere this author has this ID, it's going to set a new key of isFeatured to true. And I say upsert false because I don't want anything new to be created, and I want to update multiple, so true would be the last parameter. So now when I go and find those, you'll see a new key isFeatured as true on both of these. Try to move quickly here. So this next one basically goes and looks through all blog posts that have a tag of Buffett. And so you'll see the second post is the only one that has a tag of Buffett, and I want to say okay, well, add a new key, rockstar of true. And so it's going to do it for all of them that have a tag of Buffett. And so although it was a list, I'm still searching by a string, which is pretty convenient. And so now when I come back and look at my list, you'll see this guy had a tag above it, Rockstar was true, and nothing was updated for the second one. I've got some other updates in here for the sake of time. Are we going to get to Sam? See now it's almost 5.
Yeah, we can play later.
Alright, one really cool one is add to set. It's pretty stellar, right? So what happens here is it basically goes in where all author IDs of 112233, it basically looks at the current tags that it already has, and it'll add a new tag if it doesn't exist, and if it does exist, it just leaves it alone because it already has it. And so let's say we want to add word up as a tag to all of our blog posts. So now when I go back and look at those, all our blog posts have word up. So let's say I want to run that again. I wouldn't expect to see it added again because it's already added as a tag. So now if I go, I ran it again, and you'll see that it's still only there once. So it doesn't duplicate that entry, which is super convenient. And you can also update that with another command of each and run through a list of things to add, which is super awesome. But I don't have time to get into that stuff right now. So how do we delete? Simply, if you want to delete by ID, so 1, 2, 3, 4, whatever, you'll see that there's 2 here now. Pretty simple command to remove. Now if I want to find all, I've only got that one left. And then if I wanted to remove all, it would just be db.log post.remove. Yeah, you can delete by whatever you want. Just don't have time to show it all. Trying to respect these people's time. It's 5 o'clock, man. It's 5 o'clock somewhere, and that somewhere is here. Alright, so db.blogpost.remove just basically empties everything out. And now if I were to do db.blogpost.count, well, there's a few other things I actually want to show you guys, but I'm not going to get to it. It'll tell me how many documents are in that collection. And as you can see, we don't have any now because I just deleted them all. A few other things that are interesting. I'm actually going to go back in here and insert these again because I think this stuff actually is pretty interesting. Okay, so if I do the count again, you'll see that there's more than one. If let's say I go and grab by, we'll do by ID, like this guy. I can do a .explain, which will actually show me what's going on when I run this query. So as you can see, it's scanned through every object because I don't have any indexes set, but this will tell me if it actually hits an index, which is pretty beneficial if you've got multiple indexes to see kind of what's going on, and if things are truly being hitting indexes and they're not scanning every single document in your collection because that's quite expensive. Yeah, there's a few other things I could get into as well, but we'll start wrapping this stuff up. So I put the code snippets in there if anybody wanted to go back and look at the slides later on, review that stuff, whatever, check it out. These are all the retrieves we did, the updates, the deletes. Tips. As I was mentioning before, if you have really big key names in your documents, that's going to make your collections really large, which is actually going to slow down your searches when you get hundreds of thousands of rows. So one thought would be to shorten your key names. The problem is that makes your keys, when you go to look at what the documents are, it's really ambiguous as to what that could possibly mean. If I see something that just says S, what exactly is that telling me? And there are a few third-party tools out there which you can kind of plug in, like MongoKit or Mongo Engine for Python, which are pretty awesome because then you can add stronger types to that, and it's all kind of kept behind the scenes from what those keys actually are, and you can define the keys to be like single letter. So then it's stored super small, but when it's pulled back, it's given it more readable. So when you're going through and actually developing with it, it's not you're not doing whatever .s, get me whatever S is, and let me go look at the doc to figure out what S was. Be smart with your indexes. If you index absolutely everything, there's a chance that you might run out of memory and not everything will fit in an index. If it doesn't fit in an index, the search can't find it in an index. It's going to have to go to a disk read, which is pretty expensive. So yeah, design your documents wisely. Like I said, there's size limitations on them, so you can't just throw everything in a single document, but you can throw a lot in them. Hope you enjoyed. Any questions?
So you said that the object IDs are fluid and they are really hard to read, and you guys override that with something else. So what else do you use to have a globally unique key instead of an object ID?
We use a random hex value with both uppercase, lowercase letters, and we basically define a list of letters to use in kind of a different algorithm, so you never put like 3 letters back to back, a whole bunch of randomness, but basically we can generate that. So we still run the risk of potentially creating 2 IDs that are the same, but I think we actually ran a test on it and it took like 2.5 million iterations before we actually hit the same ID, and that was with a lower number. I think that was with like 7, a length of 7 characters for the ID.
We basically do YouTube, basically an algorithm kind of like YouTube. You know how YouTube's IDs are relatively short, but they have a lot of different characters. We just wrote a simple algorithm that kind of basically randomly picks a YouTube-like ID. And obviously the longer it is, the stronger the guarantee of uniqueness. So there's just depending on your domain, you know, there's some domains where you don't need to worry about having trillions of documents. There's some you do. So.
Yeah, and as to this point, we haven't needed it for the solutions we've needed at Cerner. So it hasn't become an issue yet. And if it does, then we just increase the length of characters, and then still should be okay. Does anybody actually use a NoSQL solution here at Cerner outside of all you guys? What do you guys use it for? Indexing. Well, what solution? Oh, so you're still Cerner Health, yeah.
Well, it's not. It's plug-in into.
Gotcha. What implementation is it? Is it Redis? Is it CouchDB? Cool. Mongo's awesome. Yeah, just dive into a simple project even, if you guys are just playing around with it. I mean, you saw how easy these examples were. I mean, even creating a simple blog post, just dive into it, start using it, and the more you use it, the less you want to go back to SQL land, all of its structuredness. Hope you guys enjoyed.